Hi all, welcome to Sidza.com. Here in this video, we'll learn about the polar and non-polar bonds. In our previous videos, we discussed about anionic bond formation and the covalent bond formation. How does it take place? And we learned that, if there is a difference in the, electronegativity more, right, then there can be the transfer of electron and you get an ionic bond. And if the difference in electronegativity between the two atoms is less, then the bond will be a covalent bond, right? All those things we have learned. Now, let's take here an example of the two hydrogen atoms. In the H2 molecule, we know that two hydrogen atoms, the difference in the electronegativity is almost zero there, right? Because these are the homonuclear atoms, so the difference is zero. Correct. And if the difference of the electronegativity is zero, right, then we know that the electron pair will be right at the center and you get a a covalent bond, but that will be a non-polar, right? It will be a non-polar. So that means if you normally get a bond between the two atoms where there is no difference in electronegativity, right, electron pair will be right in the center and you get a covalent bond. And you get what type of covalent bond? Non-polar covalent bond. Normally we have a benchmark of 1.9, right? 1.9. If you have a difference in the electronegativity more than 1.9, then obviously the bond is an ionic bond. Correct? The bond will be an ionic bond. Let's take an example of the sodium chloride. We know that in a sodium chloride, NaCl, the bond is ionic. Sodium, it loses the electron, chlorine gains, so there's a transfer of electron from sodium to the chlorine. It's because that if you look at these two atoms here, sodium is having the electronegativity of how much? It is 0.9, and the chlorine has an electronegativity of a 3.0. So the difference here is 2.1. The difference in electronegativity is 2.1, so the bond is ionic. Okay. So we can say here, if the difference in electronegativity is more than 1.9, the bond is ionic. But if it is less than 1.9, correct, it will be covalent. So right now I'll take another value, that is 1.6 rather than 1.9. If the difference in the electronegativity is 0 to 1.6 rather than 1.9, it is this much, then the bond is covalent. Okay, the bond is covalent. However, if the difference in electronegativity is very, very less, 0 to 0.5, up to 0.5, right, then the bond will be non-polar covalent bond. Here, always the bond is, non-polar covalent bond. Like you can take an example of the hydrogen molecule. Same will be the case with the chlorine molecule. Similar atoms there. The difference will be zero. Or even you can take the an example of a methane, because in the methane you have a carbon and the hydrogen, and if you look at the difference in the electronegativity, carbon has a 2.5 of electronegativity and the hydrogen is 2.1. The difference here between the two atoms is 0.4, so we still call it as a non-polar covalent bond because the difference in electronegativity is less than 0.5. But if it is more than 0.5 up to 1.6, then it's a covalent bond. But what type of a covalent bond? It's a polar covalent bond, right? It is a polar covalent bond, right? It's a polar covalent bond. Example, you can take here the you can say it is HCl, hydrochloric acid, hydrogen 2.1, and chlorine is it's 3.0. The difference in electronegativity here is 0.9, so it's a polar covalent bond, right? So this is our benchmark now, 0 to 1.6. If it is 0 to 1.6, it's a covalent bond, right? And if it is more than 1.9, it's an ionic bond. But I know what's going on in your mind. You have a question, what about the values between 1.6 to 1.9? Correct? So let's see what will happen if the electronegativity difference is between 1.6 to 1.9? If it's between 1.6 to 1.9, now the bond can either be covalent or it can be, it can be a polar covalent or it can be an ionic. It depends what are the two atoms, right? If suppose here, now there are two cases. You can have an ionic bond here or you can have a polar covalent bond, right? I'll repeat it. If the difference in electronegativity is 1.6 to 1.9, the bond can be treated as ionic or it can be treated as polar covalent. So here the difference in electronegativity here is, you can say it is 2.1 and here it is 4.0. Fluorine has a 4.0. The difference here is 1.9. Okay, the difference is 1.9. So is it a ionic or is it a polar covalent? It is a polar covalent bond. It will be called as a polar covalent bond. It will be treated as a polar covalent bond, right? Why? Because the two atoms are both metals, right? So if both, these are both non-metals, okay, both are non-metals. Now if one of the atom is a one of the atom is a metal and another one is a non-metal. Let's take here an example of, you can take the sodium bromide, NaBr, correct? Everybody knows that NaBr is an ionic bond. Sodium will lose electron, bromine will gain. But if you look at the electronegativity data here, for sodium it is 0.9 and bromine it is 2.8, right? So difference here is again 1.9. But this is a bond between a metal and a non-metal, correct? A non-metal here. You can see the difference is 1.9, but the bond will be an ionic, right? This is an ionic bond. So we got the conclusion here. Let me write down the conclusion. If you have the difference in electronegativity less than 0.5, it will be a non-polar covalent. If it is between 0.5 to 1.6, it is polar covalent bond. If it is more than 1.9, then it's an ionic bond. And if it is between 1.6 to 1.9, it can be ionic or it can be polar covalent, right? It can be a polar covalent. Depends. If both the atoms are non-metals, right? You have only non-metals there. Example here will be HF, right? Hydrogen with 2.1 electronegativity and the fluorine with the 4.0. The difference here is 1.9, but still the bond will be treated as a polar covalent, right? Not an ionic, because we have two non-metals there. But if you have a metal and a non-metal, right? If the bond is between a metal and a non-metal, and the difference in electronegativity is what? It is less than, you can say it's less than 1.9, between 1.6 to 1.9, then it is a ionic bond. Example, we can take sodium bromide. The difference here is, sodium is 0.9 and the bromine has an electronegativity of 2.8, and the difference will be now here the 1.9, okay, but the bond is ionic. Hope you got the concept. Thanks for watching the video. Bye for now.